In this question, we'll rank the electron affinity of this list of elements: silicon, sulfur, phosphorus, argon, and chlorine. Electron affinity is a measure of how much energy is released when an atom takes an electron. Now, in general, electron affinity increases as we go toward the more electronegative atoms. However, this general rule has a number of exceptions. First, certain groups in the periodic table will have a lower electron affinity than expected, and will break this trend of more electronegative atoms having higher electron affinity. We know in general our electronegative atoms tend to be in the upper right corner of the table. Most of the time this trend will hold. However, the exceptions to this rule occur in Group 2A, Group 5A, and Group 8A. The reason why this would happen in Group 2A is because in Group 2 we have S2 and no P's. We have a complete shell and an empty shell, and adding an electron in would break that stability, keeping in mind that empty shells are stable as is, and so anything from Group 2A would not want to take an additional electron, and therefore you wouldn't release any energy. In fact, it might be slightly difficult to force it to take that electron. Group 5A has a similar problem in that its configuration ends with S2P3. The S2 is a complete subshell, and the P3 is a half-filled subshell. That's also stable, and so putting an electron on anything from Group 5A would not be as favorable. Therefore, its affinity would be lower. Group 8A has a similar problem because its configuration ends with S2P6. You have a full subshell for S and a full subshell for P. Therefore, taking on an extra electron would not be favorable for anything in Group 8A. That new electron would have to go on the next level up. For example, neon is on level 2. Therefore, if it captured an electron, that electron would have to go into level 3. Therefore, any element from these groups will have a lower electron affinity than expected. Another exception is that anything from row 2 on the periodic table will be lower than expected as well. So any of the elements lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, or neon, all of those elements will have smaller electron affinities and will not follow this trend. Therefore, this trend on electron affinity only holds for levels 3 and downward from there. The second row will give us something smaller than the others. So we need to keep these exceptions in mind as we write our answer. Now let's locate the elements on the table. Silicon, sulfur, phosphorus, argon, and chlorine are these elements in row 3 of the periodic table. In general, we would work left to right. However, 2 of these elements are in the exception groups: phosphorus from Group 5A and argon from Group 8A. So we should consider phosphorus and argon to have the smallest electron affinity. How to decide between them is thinking about the configuration. Argon already has a complete shell, and any electrons that get captured by argon would have to go into a completely new level. That is completely unstable, so therefore we say argon has the smallest electron affinity, followed by phosphorus. However, for the other three elements, we can use the periodic trend working left to right and bottom to top. Since silicon, sulfur, and chlorine are all in the same row, we just work left to right, and we would say silicon is next, followed by sulfur, followed by chlorine. And this is how we rank electron affinity. This can be tricky, so we always have to keep our exceptions in mind as we try to rank it.